Welcome to today's webinar brought to you by Onymos, Domo, and Couchbase. I'm Stephen Fegg, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Bringing the Power of AI to IoT, Data Strategies, and Enabling Technologies. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, I'm excited that we have with us Shiva Nathan, CEO and founder of Onymos, David Brader, Senior Practice Lead at Domo, and Mark Gamble, Product and Solutions Marketing Director at Couchbase. I'm going to pass the event over to Shiva to kick us off. Welcome to the broadcast, Shiva.
Thanks, Stephen. Thanks for having me here. I appreciate that. Everyone in the world would already know about my company, Onymos. 8.5 or 9 billion people on this planet should know about this. The reason being that we are the opposite of anonymous. That's how the name came about. Onymos. So since everyone knows about this company already, let me move ahead and tell you what we do. Almost every enterprise in this planet is building one or different kinds of applications, either IoT applications or mobile applications or web applications. If you open the first layer down and then look down and look at what's in an application, there are a lot of features. You bring a bunch of features and put them together, and that's what creates an application. There are features like login. Almost every application in the world has a login. Every application has a data store to push the data to. Some applications have chat. Some applications have notifications. Some mobile applications have geolocations and so on. And we are in 2023, and yet every enterprise app development team in the world is building the same features over and over again. So 5-6 years back, when I founded this company, Onymos, I thought, why should everyone be reinventing the same wheel? And not just that, with the pace at which this technology is moving, everyone has to keep this thing maintained. Login of 2020 is not the same as login of 2023. You have to go back and update your login mechanism to take in the latest security features of login and so on. So what Onymos does is this: we provide a platform of what we call core or basic services out of the box to enterprises that wants to build applications, so that your enterprise software development teams are focused on what makes your business unique, rather than focusing on, did I upgrade my application to the latest API changes from Stripe or iOS 17 or Android or whatever be the case, whatever APIs that you build are dependent on. So out of the box, we give a pre-built set of software commodities, or what we call them features, or features as service, that enterprises pick it up and then they build their applications on top of. You focusing all their enterprise talent on what makes their business unique. Currently, we are a Series A company. We are focused on the health and education technology verticals. So that's what we are focused on currently. And I'm sure when I talk about this, people are already thinking, oh, if I'm building an IoT application, or if I'm building a web or a mobile application, oh, how can I trust this platform? How can I build on this particular platform that's from this third-party vendor? Would that be as good of a quality as if I had built it all myself, and so on? And of course, I ran a large engineering organizations before, and I know the skepticism that comes from engineers in terms of trusting another person's code and having the not invented here mindset in many cases. So that's why when we founded the company, we made a deliberate decision that we would actually license the entire source code out. This is very unique in the software industry. Your source code is your intellectual property, and yet we as a company have been successful in licensing the source code. Of course, we do that at a much higher price tier. At a slightly lower price tier, we actually license you the software library that encompasses all your set of features, your login, chat, notification. We have 20 such features out of the box. that you can just pull in either one at a time or get the entire platform if you're building a net new app. Or if you already have a application and you go, oh my God, iOS changed how bio-authentication is done because now they're going to start including retinal scan. And I've already done fingerprinting. I've already done Face ID. And now I have to work on retinal scan. You can come to Onymos and pick up our bio-authentication feature and build your application on top of it and never have to worry about maintenance from that point on. We are a subscription business. We will license the entire source code. And not only that, we will keep updating the source code every quarter and ASAP if there's a security problem or a security vulnerability that we can fix. And nothing's better than having the source code or the code library. The way that I explain to the CTOs is this way, which is, imagine your entire team slept tonight, woke up the next morning, and all this code is magically checked into your source code control system. And not just that, that source code control system is being magically maintained by updates from this company, Onymos. The second part of the uniqueness that we offer is what we call no data architecture. If your team built an application, an IoT application, would you want your data to go to someone else's control, someone else's cloud, someone else's endpoint, and so on? Absolutely not. So when you use the Onymos platform of features, what you do essentially is that you take the library or the source code, whatever you purchase from us, you build the application, you roll the application out, and the data from your customers using your application goes to your endpoint. It could be your cloud endpoint, it could be your on-prem endpoint. Onymos at that point is not in your data path. We are not able to seize, hear, say, or control your data. We are just not in your data path at all. So that provides the heightened security things that you can do. Given the licensed source code, you can run all kinds of security testing, vulnerability testing that you have. Of course, you can feel free to go change the code that you want. When you do that, you're responsible for the merge effort when we bring in the next set of changes. Or you can tell us the changes that we made, and we will roll that in as well. So high intellectual property or IP, owning that within your enterprise, within your software development team, gives you that ultimate highest security possible. It's as if your engineers wrote it. And now I'll jump into a particular use case, one of our customers, and why they chose us and how they use us and so on. So this is a company called Vapotherm, next generation medical device company. So what they do is they have a very innovative technology where for patients that are to be intubated, they provide alternatives to such patients where they can do high velocity therapy through the nose so that the patients don't need to be intubated through the mouth. The patients can talk, can eat, and even be ambulatory within the hospital premises. And this particular device has been around for like many years now, has been continuously on the bedside. When the numbers on the device change, the nurses, the physicians all have to run into the room where the patient is, look at the numbers, and then provide a different treatment plan for the patient. In some cases, they'll have to page a duty physician who is miles away and bring the patient in, the on-call physician in, the senior physician, to decide what they have to do. And when they were looking at, hey, I want to think of this like device, which is an edge device, and they want to bring this data to the cloud and do all the fancy things with the data, including for physicians to look at it, plus being able to consult with physicians 3,000 miles away or across the world, being able to take this data and do that, plus also anonymize the data and do a lot of data analytics on that particular data, use it for research purposes and so on. And when they wanted to do this, of course, all of this had to be FDA approved and so on. So they were planning to build this all internally, and they had a long plan where they would actually have gone in 2025, starting in 2023. They would have gone for FDA approvals in 2024 and 2025 and so on. We went in there and said, hey, here is a platform for you to build this IoT application out of the box. You get all the pieces that you need in terms of grabbing data from the edge device, having a gateway within the hospital system to triage the data, process the data, and then have a data store to push the data to the cloud, and then pull pull the data from the cloud for the physicians and the nurses or whoever it be for visualization and stuff. We provided an entire platform. So their engineering team is now focused on what makes them unique, which is the nuances of the device, nuances of the data itself. That's what they are spending the time on. And net, what happened was that the timeline got compressed so much that they could actually go for FDA approval even this year. Instead of having to wait another 9 months or 12 months, that would have taken them to build all of this stuff. So that's how we are revolutionizing how companies are building IoT applications, web applications, or mobile applications in the healthcare space. And then once you have the biggest concern that they had was, what happens to this important data, the patient health information or PHI, or protected health information or PHI? Where does the data go? And we said, we offer you our platform, and the data from the hospitals go through your application that runs on top of our Onymos platform to your cloud endpoint. We are not in the data path. So it makes the HIPAA approval, the FDA approval, the regulatory processes, all of that so much more easier. And the data gets transmitted directly to their GCP endpoint. And what's next in the roadmap for Vapatham is that now that you're able to collect all of these data from devices and edge and endpoints from hospitals and even at home use cases and so on, they're able to bring all of this into the cloud. Of course, they have anonymization of data because it's protected health information. They can anonymize the data and now run AI and machine learning systems, machine learning models on top of it to be able to augment what the physicians can do. The physicians are provided intelligence based on the data, based on the machine learning and AI models that they've done. They were able to provide the physician saying, hey, of the 20,000 patients that we saw with this trending chart, following could be what the patient's condition could be, or following could be a treatment plan. And of course, given it's a medical device, there'll still be a human in the loop for a long time to come. We are not at the stage yet where AIs can replace physicians. But it provides a lot of on-the-time analytics that an individual physician or a team of physicians could have taken hours or days to have done. Machine learning and AI can actually help with all this data analysis based on all of the data that's now central to be able to provide them treatment plans and so on. So to summarize what we do, we, Onymos, provide a platform that lets enterprises, health tech and educational tech right now, but it is a horizontal platform that can be used in other industries as well, where you get a set of features as services that your team can start use to build your applications on top of. And you don't have to worry about maintenance of the features that you get from Onymos, because that's our bread and butter and that's our business. We will continuously maintain those features for you every step of the way. Thank you. And back to you, Stephen.
Very much, Shiva. That was a fantastic customer success story. It's my pleasure to reintroduce our next speaker today, David Brader, Senior Practice Lead at Domo. David, welcome to the broadcast.
Thank you, Steve. Yeah, we're going to try to move along here a little bit, so hopefully I won't be too brief. Really what I want to talk about is the fact that data in and of itself, and I hope this is somewhat provocative for some people in the audience in terms of questioning, data in and of itself is useless until the point that we actually turn it into action, right? And that's either going to be through electronic digital means or through human behavioral changes. We're going to do something different in the real world. So if we want to talk quickly about what the data journey is to bring us back to this, IoT just being another source of data, is that ordinarily we're talking about having to be able to connect, meet the data where it's at. And this can be anything from mature data lakes to other SaaS tools, all the way down to oftentimes we're trying to combine IoT data or IoT data, even with things that live in spreadsheets or other disparate sources within an organization, be able to bring it together, join it, automate those processes, and then deploy it into analysis, whether that's going to be through visualizations or stories, but then also to control that entire process by being able to, when you do create transforms and higher level analytics of your data after you've brought it together, to be able to control those processes and make sure that no one is getting in there manipulating those, such that the value you saw today is not the value you see tomorrow because someone's actually made a change. but then also to be able to deploy it and into the action layer, whether it's through alerts, sharing, mobile, however you might want to do, or even through business process management or workflows where you're going to actually institutionalize and automate actions happening within your other digital systems, maybe even down into the field level, or certainly across other humans to make sure things are happening based on that data. So when we talk about IoT or IIoT, from the industrial side, a couple things to keep in mind that are pretty important. First, we're going to have multiple concurrent cycles that are going on. And what I mean by that is value cycles. IoT data is typically very valuable at its initial acquisition. And as we've all seen the bathtub curve on the value chain of data, as you go through its life cycle, it tends to then level off and drop as it gets into the mid-cycle. But then it becomes more important again as you aggregate it into broader time horizons and with more data. So understand that you're going to be taking advantage of it both as a point of data, whether it's an event or whether you're going to turn it into a time series, but also then you're going to take advantage of it or need to be able to take advantage of it when you combine it with other parts of what's going on in your business through your ERP, other sorts of systems. So you need a system or something that can meet the data where it's at, where it originates, whether that's by being able to connect as a broker or to your brokering, or to any other source of data you might have throughout your entire network. You want to be able to easily build reliable feeds and then transform that in line if need be. Sometimes those transformations are broader and they happen more in a centralized situation where you've brought multiple data sources together and now you're transforming the data. But a lot of times you're going to have even initial transformation on that data that you're ingesting real time from IoT devices. That also means you have to be able to store and query with rapid capabilities. On top of it, we want to put into it, we need to expect an integration layer that's going to allow you to analyze. This is where you can run and deploy your models. This is where you would continue individual and critical associated data rapidly. So again, the individual data points are being looked at for either alert, outlier, or exception case basis. But then you also want to be able to have other forms of that rapid deployment in terms of, I've now brought that into other models that are looking at longer time horizons, taking other actions and putting out other alerts or other change conditions. The visualize, again, at a certain point, no matter what we decide to do with multi-tier, whether it's device to edge to cloud and then back down, at some point, the human's going to have to be able to visualize what's going on, even if the machines are taking directive action electronically as data is coming in. And so I want to make sure that we're still providing that same level of visualization on both the real-time data as well as the broader, fully aggregated data, so that human cognition and expert opinion can come into play, and so you can build this into your modeling. And what you can see is as we go through the life cycle here, you're going to have many times where, as a human is now visualizing and taking a look at what's going on, we're going to go back and we're going to either change how we're ingesting or how we're querying or how we're analyzing that data. And you need an environment that makes that very simple and easy to do so that you can continue to get more and more value out of the data that you're acquiring. And finally, and again, most importantly, it has to be driving action. So you want that to be having direct human involvement. This can be either through, again, visualization or passive alerting, but also through apps or other more boutique solutions that can happen within the entire environment. Integrate your workflow so you can take action on anything that you see, that you can actually have a system that's going to bring that in and then say, okay, based on this anomaly, we want to write this work order over into our maintenance system, or we want to go ahead and make this sales order. We want to let the customer know that there's potentially going to be an issue in delivery and so forth. You want a system that can actually take it from cradle at the IoT device and data level all the way to that end value to customer and business process improvement. And so when we talk about unique challenges that we see with IoT and AI, and again, in this case, AI, I'm referring to machine learning and not just large language models, as we're all aware of. We do need to make sure that we have the capability of dealing with the high rate of speed and the high volume of data that's going to be generated. Again, they're small packets, but there's lots of them. They happen quite often, so you want to be able to grab that in and deal with that at the right frequency. That means you need to have multiple ways of storing, whether it's through large buckets like S3 or others, but also time series databases, perhaps Pinio, whatever. You want to be able to make sure that you are storing the data at scale and speed, and then you have easy and accessible ways to pull that data back out in order to deploy your own models, do your own visualizations, and create your own business processes. And so that environment is really what becomes key. You don't want many different tools to have to try to achieve that. If you can bring that all into one or under one umbrella, it just makes it so much more seamless and so much quicker time to value, easier to update and maintain. And then obviously, finally, as we talked about, we do want to be able to take through alert, retrieve, and aggregate so that we have the full layer. And at the aggregate level is really where we start to talk about the newer things that have come up in AI, whether it's large language models and being able to interact with whichever one of your choice you may want on that data, et cetera. Remember, IoT data in and of itself is not really going to play very nicely at that layer because it's either going to be event or time series. You're going to need more context to really turn it into something that LLM is going to play on. But in between, you'll have been able to deploy many different types of machine learning models for quick and rapid data analysis and action taking. And so additionally, a couple things that we don't want to lose sight of, you do absolutely need security and access control. And that includes not just security on what can and can't be transferred and what devices can be communicated with, both in read and write, but also in terms of your data sets, your governance, all the things you've set up in an environment to make sure everything's happening properly. You want to make sure you have control over that, version control, et cetera. And then you also want to be able to have a way of having a prod and a dev environment so that as you're deploying new things, you can control before you release for quality control. And then lastly, if we were to visualize this, and this is where I come from, is a fully integrated platform that allows you at scale and speed to grab data wherever it is, whether it's IoT, whether it's coming from PLCs and being published through MQTT, whether it's your data that sits in your distributed systems, your WMS, your MES, ERPs, wherever it may be, your sales systems, et cetera, your CRMs, be able to bring all that together so that you are aligning the data properly for full business and action value, as well as being able to write back and forth between the systems based on what's going on. So bring it all into one environment, be able to coordinate it cohesively so that you're building the right contextual stories around that data. Have an AI layer, which we have integrated, where you can deploy not only models you create or third-party models, but also integrate LLM capability and language to query capability and so forth within that same environment. And then be able to take those results and not only visualize and have your people work off the same sheet of music, but also be able to write back key things to the host systems as desired in order to make the right business actions happen. Again, the key is take data to actual behavioral change, whether electronic or human, and not just acquire data for the sake of acquiring it. With that, I'll turn it back to Steve.
In there. Okay, it's my pleasure to introduce our final speaker for today, and then we're going to have a nice group discussion. Mark Gamble, Product and Solution Marketing Director at Couchbase. Mark, welcome to the broadcast.
Thanks, Stephen. Great to be here again with you guys at DBTA and follow some awesome presentations from my co-presenters. For the next few minutes, I'm going to be talking about Couchbase and Couchbase Mobile. It's the database solution that's built for Edge and IoT. And I'll specifically explore how it can really accelerate the development of the AI-based features and capabilities for IoT and Edge applications. So let's dive right in. As we dive in, a little bit about Couchbase, just to set context and a frame of reference for the rest of my presentation. Couchbase is a cloud-native NoSQL database that's used to power gigantic applications like LinkedIn, Tesco, Comcast, Amadeus, United Airlines, and more. Big enterprise customers who use us to power their critical apps. And Couchbase is multi-model. And this means that it's a combination of NoSQL concepts. First, it's the processing of key value information in memory for hyperfast responsiveness. And coupled with this, it's the distributed storage of JSON document-based data for flexibility and resilience. And to this, add full support for containerization, add mobile and edge capabilities, which I'll be diving further into, and a full set of built-in features like SQL query support. This is not typically found with a document database. And on that, we add full text search, time series support, streaming, eventing, analytics services. These are things that customers no longer have to bolt on from a bunch of different database technologies. And with all of this, you sort of have Couchbase in a nutshell. And it so happens that with our embedded database and built-in data sync, coupled with our cloud database, we are ideally suited for high-velocity IoT applications. And don't just take my word for it. We're super proud of the fact that the readers of DBTA, in fact, voted Couchbase Best IoT Solution for 2023 in the Reader's Choice Awards. And we also took finalist position for Best NoSQL Database. And we're super proud of this recognition. We think it speaks to the strength of our database offering for IoT and edge applications. So let's take a quick look at why that is. So here's kind of a typical edge architecture where red icons indicate databases and red lines between the database icons indicate data synchronization. So we have a cloud data center, a near proximity edge data center, and this could be a co-location data center, running in a city or on-prem or on a rack on a cruise ship or oil platform or even running in a retail store. And in this depiction, there's just one middle layer for simplicity in this tier, but it represents N tiers, if you will, between edge devices and the cloud. And we have data processing embedded to edge devices where appropriate. And the gray boxes represent the network layers. And as typical for edge architecture, this type of topology makes apps faster and more reliable by processing data in progressively more local tiers and removing those internet dependencies, right? And it insulates downstream layers from upstream problems. If the internet goes out, heaven forbid, or the data center and somewhere in the layers goes out, edge apps in lower layers keep on running. But the key is you really need a database designed for the edge to do it right. And Couchbase fits seamlessly into this architecture. It runs in the cloud, at the edge, and on device. And most importantly, it automates data synchronization between those layers for consistency. So, with this picture in mind, let's transition to the kind of AI and ML component. First, as it applies to the server layers in the cloud and edge tiers. So the Couchbase Capella columnar service is an operational real-time analytics data store that is part of Capella, which is our managed and hosted database as a service. And this is essentially a parallel data management capability, allowing for the running of complex analytic queries against operational data without any impact to operational workloads, and without the need to move data into a separate repository for analysis. It's great for real-time analytics on operational data. It can be used as part of a data pipeline for machine learning training iterations, for example. But it also brings the ability to leverage fully trained ML models via user-defined functions. And essentially, this is the ability to call trained ML models right from the database using Python. And that is to feed a given set of data to the model and incorporate results back from the model and pass them back to the application. So Columnar is now in private preview. If you want to check it out, you can go to couchbase.com. But now on the edge devices themselves, we have Couchbase Lite. And this is the embedded version of Couchbase that allows for processing data on device. And it supports C, which allows it to be embedded to lightweight apps on resource-constrained devices like agricultural drones or surgical instruments, as we saw in Shiva's presentation. This local data storage is how we provide that high speed and availability for apps. And Couchbase Lite has a really cool feature called Predictive Query, the Predictive Query API, which can be used to call trained mobile ML models at the edge, using application data stored locally within and captured by Couchbase Lite, which provides real-time context for things like AI prompts. And it also makes the experience fast and always available, even when offline, because the data is there local. So a typical use case of predictive query is like image recognition for matching or search type applications, and recommenders for contextual suggestions. So taking into account those capabilities, sort of the final punchline. And of course, I'm being brief so we can get to our panel discussion. But Couchbase processes data and AI in the cloud, at the edge, and on the device. And that brings the scale to handle massive amounts of data required for edge, for AI, and the edge capabilities for really the immediacy to make it effective. So looking just for a moment at some customer IoT use cases, the applications I think are also really cool. What our customers are doing. Foundries.io offers an IoT infrastructure platform for their own customers' edge apps. And Couchbase is used for capturing and processing the data for a variety of really novel use cases. My favorite is robotic vacuums, where it basically a fleet of Roomba-style vacuums autonomously service rooms in hotel chains. And they work without connectivity and are smart enough to know when a room is empty. They can detect and get around or even move obstacles. They're smart enough to know and recommend room layout optimizations by leveraging kind of history. And they can use those data patterns over time to do so. It's kind of a perfect example of a Couchbase powered edge app. Arthrex is another in medical. They embed Couchbase like to their orthopedic surgical instruments to capture media metadata from the tiny cameras in the device, and it syncs it to hospital systems for real-time evaluation and post-op review. And Princess Cruise Lines, if you've ever been on Princess, awesome experience, largely due to Ocean Medallion. This is the wearable IoT device program that they give to every passenger on every voyage, and it opens their doors and allows them to purchase amenities, and it tracks passenger movement as well. And Carnival Princess Cruises standardize their IoT platform on Couchbase for providing that hyper-personalized voyage for every one of their passengers. So hopefully you've enjoyed that very short little tour with Couchbase Mobile and our IoT capabilities. And with that, we'll turn it back over to Stephen to continue the program.
Thank you very much, Mark. Really cool examples. I think we could probably use a fleet of Roombas here, but totally different topic. So at this point in time, we're going to dive into a nice group discussion. I've got some questions, and the first question is, IoT sensors can create massive volumes of data, but much of that data has a limited shelf life in terms of its value for process control and optimization. Real-time data analysis is essential to IoT applications, but the scale and performance required is also a challenge for many organizations. How is the convergence of AI and data analytics changing the status quo? And Shiva, why don't we start with you? Hey, Shiva, are you still on mute? I feel like I can't hear you.
Yep, I was. Sorry
Nope,
about that.
no worries. Cool.
Okay, I'm back here. Give me time to think about the answer. So let's say 2 days back, my heart rate was 60, my pulse ox was 99 or whatever, and then that data is getting measured every 3 minutes that Apple Watch does now, right? How relevant is that data today? It doesn't matter because I was fine and alive then, I'm fine and alive now. That's the amount of data that we are collecting today. And we are collecting for every person that wears an Apple Watch or whatever IoT device that the person is wearing, right? And you bring all this 5-10 years back, let's say we have all this data. What could you have done with it? You would have probably put it into a database before Couchbase and Domo and everyone was around with their solutions. We'd have probably have to run a lot of querying the database to figure out how can I use this data, whether I can use it. But today, using AI and ML models, we can consume all this data and then quickly find out, hey, if my heart rate when I'm sitting down is 100, I'm having a heart attack probably. Shiva alerts me, Shiva goes check it out. Or you can also look at trends and go, if my heart rate went 60 to 65 to 60 to 65, 65 like a pattern, and I've told it already that when that pattern happens and I fainted on Monday, it can now look at predicting the next time I'm going to faint, hopefully never, right? So 3 ways that this actually helps is, one is real time. It can alert based on the machine learning and model after throwing away all the bulk of data once a machine learning model gets created. It can also do prediction. You can also do personalization. You can personalize to me and tell me how my health is doing, right? So that's where the AI and data analytics are really helping when it comes to dealing with the IoT sensor data overall.
Thanks, Shiva. David would love your input on this one.
Sure. So going off of what Shiva said, I think a couple things to keep in mind when we talk about IoT data. Again, at the very near time horizon, you're going to be looking at almost stimulus response. So quick outlier detection, quick anomaly detection, follow-up for action, investigation, threshold exception. Those kinds of things are all going to be almost like your local level control, where you're going to say, I've seen this. This is a high level issue. Go do this right away, or go investigate this right away. So you do need systems that can see it and do that immediate processing. Although that immediate processing is typically not intensive, it's just a matter of being able to acquire it from all the sources and pass it through the filters and get the data back. It's not so much that each individual analysis is taking long. But then most importantly, what you typically do is you turn that instantaneous event data into some form of next level aggregation, whether it's a time series data stream or whether it might be events for other type systems. An example might be if you're looking at vibration on a motor, right? I'm concerned about the vibration right now, but what I'm more concerned about from a longer term standpoint is, what is the fingerprint of the FFT been over time? What is that waveform changing? And can I now turn this into a time series analysis where I can now start to predict I have time to failure of whatever? And those take a little bit more analysis and a little more visualization, but you also have more time. So you need a system that allows you to execute at the immediacy level, which is, again, very, very light level, very, very much just stimulus response. Be able to bring in the data, process it, turn it into new things, whether it's combined with other things or whether it's itself turned into time series, and now do further analytics on it, and then eventually build it into your other predictive models and the rest of your data coherency, so you can start to ask LLM questions off of it as well. Like, when this data or when this signal has done this in the past, what have I seen, or what else can I pull from it? You need to be able to build that as a historical record in order to do that. So again, short term, be able to handle it at scale, but speed, light level, and then be able to store and aggregate it into additional forms of data that you can now take much more value-added action off of.
Understood. Mark, what's your viewpoints at Couchbase?
Yeah, I mean, great answers, and 100% agreed with my co-presenters that, of course, my answer is firmly rooted in the database perspective part of the equation. And I'll lean into kind of the need for real-time data analysis for IoT as a challenge. And it's really about volume and velocity of data, right? There's so much coming so fast that it, in fact, can become a barrier to insight and actually stall progress and stall action. So I always love to use examples. And there was a McKinsey study a while back on data challenges in oil and gas. And they found that a glut of data that's produced on like oil platforms, for example, comes so fast that it's really impossible for the operators on board to assess it all, right? There's data from valves and pumps all over the platform, and readings from downhole sensors. And there's other things that need to be evaluated, like sea temperature and wave height and salinity. And sending all of this to the cloud for evaluation also adds a ton of latency and expensive satellite bandwidth to the equation. And, it's the immensity and speed of data so much that instead of risking safety, McKinsey found that operators actually reduce production. They slow the process to manageable levels to the tune of only operating about 70% of total potential production per platform. Imagine what that extra production could do to lower gas prices, right? And as such, a lot of O&G providers are kind of turning to edge computing and AI augmented analytics to help out, right? By moving data processing to the other side of the network onto the platform and analyzing it there, they can better accommodate, that velocity and handle the local data at scale because it's local, right? Specific to that platform and not part of a larger corpus. And local AI models can help filter out the noise and focus on the exceptions and anomalies and all that important stuff that needs to be surfaced up to the human overlords, if you will. And all of this results in greater safety and higher production. And I think that little example sort of encapsulates the change that AI and analytics can really bring to the status quo in general. I think we're going to continue to see this type of innovation.
That's really interesting. So I'm going to move us on to our next question. What are some of the misconceptions about AI tools and services, especially the ones that are most relevant to organizations building IoT products that you've encountered? And Shiva, why don't we start with you again?
Sure, thanks, Stephen. Going back to the examples that Mark and David mentioned, right? So AI is magic, is what some people believe in. So going back to that oil and gas example that they gave, I'm sure Mark felt that when he went there, he said, "Oh, can you make my production 110%? Because you have AI now." And that's one of the biggest misconceptions that people have about AI. Or going back to David's example of motor vibrations and being able to say, "Hey, you use AI. Can you somehow stop the motor from vibrating at all?" So that's how the big conception is that AI can do magic. That's the first one. And the second thing that people don't really understand is the size of data set to train the ML models. Oh, can I just give you like 3 data points of one motor or oil and gas and be able to train it and then make it all better and good, right? That's the expectations. So people have to really understand that, no, it takes a lot of data to train a model. And the third is the time and human effort actually it takes to train the artificial intelligence model. It might be an irony, but we still need a lot of human brain and human intelligence to train these machine learning models. So to summarize 3 things, right? People think AI is magic, which is not yet, and the size of data set to train, and the time and effort to train it. Those are the big misconceptions that I find.
Understood. Mark, are those in line with what you see, or any you'd like to add?
I mean, 100%. It's taken right from our playbook, Shiva. Agreed. You know, what I've seen is an initial overdependence on AI to work magic in terms of handling and taming data sprawl. And, you know, many AI initiatives have started by collecting tons of disparately formatted types of data, you know, IoT, operational, unstructured, structured, and the like, dump it into a central repository and hope that smart AI processing will, you know, reconcile the differences and sift out the noise and, you know, introspect the data and come up with epiphanies of insight that will change the course of business all by itself. And of course, this is not the case, as Shiva very eloquently stated. You know, AI is transformative, but it also needs specificity. It needs correction. It's imperfect. It's subject to issues and hallucinations or bias from bad data. In fact, the more complicated the corpus of data provided to AI, the more likely it is to make a mistake, right? And the harder it is to trace the exact data that fed a given assessment. So the old adage of analytics applies here. You know, bad data in, bad data out. Organizations really need to know this going in and make sure their data footprint is kind of as clean as possible for the most effective AI initiatives.
Understood. David, I actually have a different question in mind for you to kick off, unless you wanted to weigh in on that one.
No, that's fine. Go ahead.
Okay. So the next question I'd really like to dive into, edge computing. Edge computing is becoming more mainstream as a foundational capability for IoT, allowing organizations to process data locally for rapid decision making. Recently, edge AI has been gaining a lot of attention. What are some challenges organizations should keep in mind in considering edge AI?
Sure, and I think Mark will have obviously a lot to say about this one as well. But I'm gonna bring it back to a different perspective, having been an engineer running plants for a long time. First off, I think edge computing is going to open up a huge amount of value for us because it bridges the gap between what I can ask a PLC to do and what I can ask higher level controllers to do in terms of deep learning models and so forth, and do so at scale. It's also direct to the equipment, as we've seen, and so therefore I don't have to worry about connectivity, et cetera. That's the good news. The downside is the same stuff that we've heard in the previous answer, is understanding what makes sense to deploy at the edge and how you're going to monitor and control that. In other words, how am I going to ensure safely that the edge device is getting the most recent model and it's deploying it? What does the edge device do in certain situations? How do you build around the process control and safety around then the programming that's in the edge device? So I think that the only thing honestly that I think of today in terms of the two concerns is the former being the over expectation and over hype around AI in many cases, and being able to do more than you can at an edge level. But then the other one is making sure that because you're going to define that it must bidirectionally communicate, making sure that's secure. Because right now you can handle all your data methods, and especially with IoT, with air gapping, you can do this in a very secure way where I'm not worried about a tunnel back in. But once now I'm actually going to be bringing information back in from the real world outside the plant via the edge device, I think that's the part that we have to be really, really confident about, that there's no tunnel back in.
Understood. Mark, how about you?
Yeah, I mean, again, echoing, David put it really well. I'll kind of jump to another nuance, if you will, and that's kind of on the challenge side. Sort of a traditional challenge of edge computing in general and AI at the edge has been, implementing it, right? Once upon a time, building out an edge architecture was difficult because companies had to piece it all together themselves and come up with the data centers and the power and cold rooms, et cetera, et cetera. And, but now there are emerging edge services from cloud service providers and network providers, things like Azure Public Mech or AWS Wavelength. These are making it much easier to achieve a multi-layered edge topology for, mere mortals. You don't have to have a gigantic IT organization these days to do it. And couple that with the CSP providers that are introducing AI services. And I'm thinking of things like deploying SageMaker on AWS Wavelength along with Couchbase for processing data and AI within a 5G network at the edge. So kind of coupling together all of these complementary technologies to keep up with the speed and immensity, velocity of data, by taking advantage of kind of these emerging services. So I definitely wanted to weigh in on that it's easier than ever, I think, to get started, and will only become easier and easier as we move forward.
Understood. Shiva, I've got a question just for you that I think is well aligned with your discussion about, you provided a great customer success story. So the question is, earlier this year, Zoom was involved in a controversy when it quietly updated its terms of service to claim ownership over its customers' service-generated data for training its own AI models. How concerned should organizations be about data ownership? What are some ways organizations can ensure they're in control of the data generated by their IoT devices?
Extremely concerned. That's what I would start with. Imagine everyone's conversation in Zoom is recorded and the machine learning knows about it. And no sinister reasons why Zoom did it. They just had the data, they just trained it, right? But imagine there's a board of directors having the conversation about what the acquisition price of the company could be. And now that the machine learning model is trained, you can actually go and ask, hey, how much can Couchbase really sell for if that has to be acquired? And maybe the CEOs and someone talked about that in Zoom, right? Or the Domo sales rep probably talked about how much discounts can they give. And you can actually go ask Zoom, hey, what is the lowest price I can get the Domo subscription at? And it'll spit out that number for you because all of this was discussed in a Zoom chat, right? So, or in very, very personal terms, let's say there was a previous company that discussed the performance of Stephen Feig on how it is. And I'm trying to hire Stephen and go, how did Stephen perform in the previous organization? It has access to all the recording data and says, oh, Stephen is a great guy, right? So that's very scary. When you have that level of information being used to train the machine learning model and being able to get insights out of it very quickly. So it'll be very concerned. But what you need to do with that is that similar to security posturing, you need to have data posturing. A lot of CISOs talk about, oh, we have a security posture. We know what security things that we're doing, but not many enterprises are still embracing a data posture. Where is my data? Where is my data going? Where is it sitting? How is it being used? Is it in my cloud instance? Who else has access to it? Or if I'm using a service, how much of the data is going to someone else's service, and what are they doing with the data? And then finally, the nuts and bolts of it is the attorneys are going to be very happy at this, which is you have to really read the click-through agreements. You have to, like, very often we go subscribe for services as individuals or even as enterprises. We subscribe to Salesforce, we subscribe to Zoom, we clicked on terms of conditions to get onto this webinar. Do we really go and read and find out how much of this data is going to be captured and how much of it is going to be used to train machine learning models? All right. So that's extremely important for us as we look at our own personal data and our enterprise's data as we go forward.
That's a great point, Shiva. Okay, switching gears here. David, I'm going to start with you on this question. How do you contend with running AI models on resource-constrained IoT devices?
Okay, so I think really the base question there is, have we established the correct model or expectation of what it can do versus what we're asking it to do? Because I don't think that ordinarily it should end up being a problem. I think if you set it up properly, you're going to know based on what the IoT the device itself is usually done, but at the edge level or so forth, what it's going to do, or if you've put in some control at the device level, you already know what it can do. I think the key is being able to do the proper handshaking and not be constrained where I don't have the ability to roll to multiple levels, whether it's edge or whether it's all the way up to the cloud to get results and then come back. It's not be constrained there so that you don't have to ask the local device to do too much, because again, the local device has a core function which it must execute, at the 5 nines kind of reliability. So I think really it comes down to more a matter of scoping and being realistic with the expectations of what you have deployed, what it can do versus what you're asking it to do. And part of that can be model management, typical things we do in model management and control, which is you take a look at how long is it taking to execute and so forth. And when you see that starting to creep, you may make structural changes to either the model itself to make it faster, slimmer, or start rolling some of those other functions up to a next higher level to take the burden off of it.
Understood. Mark, I feel like you'll have some thoughts on this as well.
Totally. Yeah, I was just nodding in complete agreement, right? I mean, ML has been traditionally done in the cloud because of sort of unbounded compute and storage resources. Seemed like sort of the only viable place to do it traditionally. But there's a number of reasons to perform ML, evaluate ML and run models locally on the edge device, speed and availability for starters. And of course, it needs to be a device that can handle it. But I think those parameters are starting to change. Smaller and smaller form factors are getting more and more powerful. And machine learning models, there's a lot of projects underway to optimize ML for resource-constrained environments. I'm thinking MobileNet and SqueezeNet. These are optimized to run on resource-constrained devices. And there's ML frameworks and libraries that make it easy for developers to integrate ML into their apps, and they leverage hardware acceleration, low-level APIs that make it really performant on a minuscule set of processing footprint, like Core ML or TensorFlow Lite, ML.NET and MLKit, among others. And I think as edge AI grows, so will the optimization of models for edge devices and the increasing power capabilities of smaller and smaller devices. I think we're going to see a lot of growth in this area going forward.
Mm-hmm.
Understood. Okay. Shiva, today LLMs and other kinds of AI models are largely unregulated. That's obviously going to change. What sort of regulations governing AI might we expect to see in the near term and beyond? And how should organizations building IoT products prepare for that?
It's changed already. So I'm sure you probably saw in the news that the European Union signed the AI Act a couple of weeks back now, I think, almost like a lifetime back now. So regulations are coming in, definitely. EU is the first national governing body that's done it. I'm sure US will do it very soon after, and then Asian countries like China and India will probably follow suit. So that's definitely going to happen. So if I had to rattle off what's in the EU AI Act, right? The risk profile of what you're doing with your machine learning and AI model, you need to really understand that. So the European Union AI Act, so I read a lot about the European Union's AI Act, and it said you have to really identify whether what you're providing is high risk, medium risk, low risk kind of a thing. And then more importantly, the thing that really affects enterprises, EU is actually asking enterprises to give the European Union all the data that you actually used to train the model on. And if it's proprietary data, at least give indications of what the data is. Of course, the devil is in the details, and that's not actually ironed out yet. But when European Union is asking for that, I'm sure US is going to ask something else of other enterprises. China and India and other countries are going to ask for different stuff. And this is like, I was talking to a friend of mine, and I was telling him, this is like you're trying to build a house without the city telling you what the building codes are, or without the city telling you how many sprinklers you need to have in a house when you're building it right now. So you don't know what's going to happen after you build it when the city comes and says, no, trash the whole thing because you didn't build it to code. And so what my advice would be for enterprises trying to do AI and ML models is that document everything, document the heck out of everything, and look at the data, what data goes into your training your machine learning models, what insights have you derived, how are you using it, and then try to do your own internal risk analysis of how risky is your insights coming from the data is, and so on. And the diagonal thing from this is that you don't want to build something that works for European Union, that does not work for US, that does not work for India or China. We want to make sure that you have to build something that actually works in all of these regions of the world and a lot of use cases. So it's going to be a complex thing. So the way to get away with that is like documenting the heck out of everything that you're doing.
Absolutely. No, I think we're going to continue to hear more about that issue for sure. Thank you for that, Shiva. Okay, I want to be cognizant of our timing here. I think at this point in time, I'd like to ask one more question, and hopefully this is an easy one. If there's one thing you'd really like our audience today to walk away keeping in mind, what would that be? And David, why don't we start with you?
Sure. It would be to really make sure that your strategy and what you're doing allows you to ultimately bring all your data together in a way in which you are not going to be beholden to any particular tech or philosophy today, so you can continue to advance and evolve as new tech comes out and new components are available. And that includes, even as we just mentioned with the case of AI, the idea of being able to be flexible as we learn more things, new things about what's going to be allowed and what isn't.
Understood. Mark, how about you?
Mine's a simple call to action because I'm a marketer. Get the Couchbase Capella free trial. The price is right. And you can try out App Services Cloud to Edge data synchronization for yourself in the free trial. So visit cloud.couchbase.com/sign up and have your first cluster spun up in under 2 minutes.
Fantastic. Thanks, Mark. It's all fair in data and AI. Okay. Last but not least, Shiva, any thoughts you'd like to leave us with?
Sure. I've told this to people, think of AI as your child. You're trying to make your child, raise your child essentially. Think about what you're going to show your child. Are you going to show a gory scene from a movie or a romantic scene from a movie? Think about how you're actually raising your child as you build your machine learning models and stuff. And at the same time, if you're going to go to another teenage kid of someone else's and going to ask them for insights, think whether you're going to take a stock tip from that teenager, another AI model, and do all your investment based on that particular teenager's stock tip. So if you start to think in terms of artificial intelligence and IoT as sensors and children rising and children telling you stuff, you'll be a lot more in a sane world as we evolve in this.
Well put.
That's an interesting way of thinking about that. I like that, Shiva. Okay, well, it is currently past the hour, so we thank you all for staying with us. I want to give a huge thank you to our speakers today for coming on board and sharing their insights and expertise. Once again, Shiva Nathan, CEO and founder of Onymos, David Brader, Senior Practice Lead at Domo, and Mark Gamble, Product and Solutions Marketing Director at Couchbase. So, if you would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. You will receive an email from us once that is posted. And again, as I mentioned earlier, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on December 29th. We'll let you know if you're the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.
Thanks, everyone.
Thank you.